Alright everybody, welcome back to Deviations. In this video we are going to be talking about the chain rule. So with the chain rule, it's going to open up a whole new slew of possibilities for our differentiating skills. And I would argue that this rule is probably one of the most important that we have in differential calculus because it allows us to deal with the composition of functions. And it becomes really powerful in conjunction with the other rules we've talked about, and it really allows us to take derivatives of some pretty crazy functions because we can use it more than once, just like the product rule. All right, so with the chain rule, we can take derivatives of functions like x plus 5 to the fourth efficiently. And efficiently is a key word because how would I take the derivative of this otherwise? I would need to, if I knew the product rule, I could split this up to become x plus 5, 2 more, x plus 5. But as you can see, this is taking a long time just to write out. And then I need to take the product rule a couple times. Or if I only knew the power rule, then I would need to distribute this binomial and then differentiate it. And that would be quite a long process. And also functions like f of x is the cosine of 5x. We have a constant in the argument there, and we don't really know how to deal with that yet. We haven't really seen functions like that in differential calculus yet. So the chain rule is really going to help us out with those functions. So what is the chain rule? So fully abstractly, given a composition of functions, f of g of x, and this can go on, we can have more than just two functions. We could have f of g of h of x. Doesn't really matter. But the derivative of that is going to be f prime of g of x times g prime of x. Now this might seem a bit abstract, so let's do a couple examples. First, we're going to take the derivative of the square root of 1 plus 4x. So our outer function is going to be the square root, and then our inner function is going to be 1 plus 4x. I like to set our inner function equal to u instead of g of x because it's easier to write out, so I'm going to write u is equal to 1 plus 4x. And that means if I want to write out my function f of u, is going to be the square root of u. And if I want to take that derivative, f prime of u will be 1 over 2 root u. That means that my f prime of g of x is going to be equal to 1 over 2 times the square root of 1 plus 4x. And that's really the hard part of the chain rule, because after this, all we need to do is take the derivative of 1 plus 4x, which is just 4 through the power rule. And that gives us 1 over 2 times the square root of 1 plus 4x times 4. And now all that's left is a little bit of simplification. We can move that 4 into the numerator, and then we can just divide by 2, giving us 2 over the square root of 1 plus 4x. And that is our derivative. That's our first example with the chain rule. All right. So now we're going to take the derivative of tangent of pi x. So this is one where we have a constant in the argument. So I'm going to set u equal to pi x, and then that means that our f of u will be tangent of u, and then f prime of u will be the secant squared of u, and that means our f prime of g of x will be the secant squared of pi x. Forgot my equal sign in there. All right, and now we just need to take the derivative of pi x, which is super easy. It's just going to be pi. That means that our derivative will be secant squared of pi x times pi. And that is it for the second example. Let's do another. All right, so we're going to take the derivative of the sine of the cotangent of x. All right, so our u, or g of x, is going to be cotangent of x. So that means u is cotangent of x. That means that f of u will be the sine of u. And then f prime of u will be cosine of u. And then we can just write that our f prime of g of x will be the cosine of the tangent of x. All right, and then we just need to take the derivative of the cotangent of x, which is just negative cosecant squared of x. So that means that our derivative will be the cosine of the cotangent of x times negative cosecant squared of x. All right, let's do another example. This time we are going to take the derivative of the secant squared of x. It's the first time we've taken the derivative of a trig function raised to a power. And you may have already guessed we're going to be using the power rule and the derivative of the secant. So first we are going to rewrite this so that it is a little bit easier to read. We're going to say the derivative of, just put the secant in parentheses and then we'll square it outside. It's a little bit more intuitive this way. Then our u will be secant of x, that means f of u equals u squared, then f prime of u is just going to be 2u, then that means f prime of g of x is going to be 2 secant of x. And we just got to take the derivative of the secant of x, which is just secant of x times the tangent of x. So that gives us 2 secant x times secant x tangent x. And then we can consolidate that just to become 2 secant squared of x times tangent x. So that is our derivative. Now we're going to do a slightly more involved example, which is going to involve the product rule. So if you didn't watch my video on the product rule yet, I urge you to do so that you don't become immensely confused after seeing this example. All right, so we're going to take the derivative of x squared times cosine of 2x. So first, we're going to take the derivative of the cosine 2x. So that means our u is going to be 2x. That means f of u is going to be cosine of u. And then f prime of u is just going to be negative sine of u. And then if I want to put that back into our f of g of x, f prime of g of x, that's just going to be the negative sine of 2x. And if I take my derivative of my inside function, that's just going to be 2. So we're going to add a little 2 here. That becomes negative 2 sine of 2x. So now we have everything we need for this product rule. So we're going to have f is going to be x squared, then f prime will be 2x, then g of x will be cosine of 2x, and then g prime will be negative 2 sine 2x. That gives us the derivative of 2x cosine 2x minus 2x squared sine 2x. And that is it for the chain rule. If you are still confused, I would recommend that you search elsewhere for some practice problems, because this is a rule you should have down cols, because it will come back in differential calculus. Thank you for watching. Please like and subscribe. See you guys later for some logarithmic differentiation. Bye-bye.